Let's start with a very simple question. Which of these two shapes is bigger? Now, depending on how you interpret that, you may say that the one on the right is bigger because it is taller. Or you may say the one on the left is bigger because it's wider. One of the primary geometric concepts that we want students to understand is the concept of area. Area is a measurement of how much space a shape occupies. One way that we have of measuring the area of a shape is by using square tiles. We can see that the rectangle on the left can be covered by 12 squares of the same size. And the figure on the right can also be covered by 12 squares of the same size. The goal of this video is to connect the intuitive idea of area with the idea of decomposing and recomposing figures. Decomposing a figure means to break it up into smaller and simpler pieces. In this case, we have decomposed both of our rectangles into squares of the same size. Now, although this works with any shape, the basic shape we will be working with are these squares. More specifically, students will be working with two types of square tiles, known as square inch tiles and square centimeter tiles. Square inch and square centimeter simply refer to a specific size. The square inch is 1 inch by 1 inch, and the square centimeter is 1 centimeter by 1 centimeter. Generically, we will call these square units. This introduces students to the basic ideas of measurement that they will be seeing throughout their education. Notice that areas are counted in terms of square units. It is not enough to say that a figure has an area of 6 centimeters. We must say that it has an area of 6 square centimeters. Recomposing a figure means to take a collection of shapes and put them together into a larger shape. The primary idea that we want to develop is that the area of a figure is unchanged when we decompose it and recompose it. This allows us to compare the areas of different figures. We can see based on this picture that the two rectangles have the same area. And we can see this by matching up the tiles with each other one at a time. When working with physical tiles, there are two mistakes that students tend to make. The first is that they will leave gaps between the tiles, and the second is that they will allow tiles to overlap. This is especially true with paper tiles because they're very thin and flat and easy to overlap. Both of these errors will cause students to determine the area of the figure incorrectly. Initially, we will start out by building rectangles out of a specific number of squares. This helps to remind students of the basic multiplication facts and starts to introduce them to the idea of factoring. Here's a typical exercise they might be asked to consider. How many rectangles can you make with 6 square centimeter tiles? Implicitly, we want to use all the tiles in our figures. With a little bit of experimentation, you should find that there are 4 different rectangles that can be made. There is a 1 by 6 rectangle, a 2 by 3 rectangle, a 3 by 2 rectangle, and a 6 by 1 rectangle. We want to think of all these rectangles as being different, even though there's a sense in which some of these are the same. The reason for this is that each rectangle represents a different multiplication fact. The blue rectangle represents the product 1 times 6 equals 6. The green rectangle represents the product 2 times 3 equals 6. The red rectangle represents 3 times 2 equals 6. And the yellow rectangle represents 6 times 1 is equal to 6. The fact that the area is left unchanged by rotating the picture is one way to represent the commutative property of multiplication. The commutative property of multiplication simply says that if a and b are numbers, then a times b equals b times a. As students get further into this section, they will connect their geometric intuition and their computational abilities. Write a multiplication sentence for this rectangle. Students are expected to be able to determine the lengths of the sides based on the picture. They are expected to see that this is a 3 by 5 rectangle. Working in columns from left to right, 3, 6, 9, 12, and 15. And the corresponding multiplication sentence is 3 times 5 equals 15. There are other ways this problem can be presented. For example, the area of the rectangle is 15 square centimeters. Write a multiplication sentence for this rectangle. In this problem, students need to use the information that's been provided to them to determine the lengths of the sides of the rectangle. This type of practice helps students to become more and more familiar with their basic arithmetic. As the numbers become bigger, it becomes harder for students to keep track of the areas. At this point, we want students to learn how to break down a large figure into simpler parts. For example, the product 7 times 14 is too much for students to think about all at once. But instead of thinking about this as one rectangle, we can decompose it into two rectangles, one that is 7 by 10 and one that is 7 by 4. Notice that the areas of these rectangles can be computed more easily. The 7 by 10 rectangle has an area of 70 square units, and the 7 by 4 rectangle has an area of 28 square units. Students will learn to write this idea symbolically. 7 times 14 is equal to 7 times 10 plus 7 times 4. And from here they can do the arithmetic. 7 times 10 is 70, and 7 times 4 is 28. When we add these together, we get 98. It should also be noted that students can break down these figures into whatever shapes are convenient for them, based on whatever patterns they see. For example, some students may notice that this rectangle can be broken into two squares and compute the area that way. Neither way is better than the other. We want students to play with the figures and explore these patterns as they go. Towards the end of this section, students will work with more complex shapes, such as these. The basic idea is to use decomposition to break each figure into rectangles and then work with the individual rectangles. We can see from these examples that there are many ways to decompose a figure. Sometimes they will just be given measurements and will need to use the geometric intuitions that they've developed in order to figure out the sizes of the rectangles. While it will be important for the students to realize that the answer to the question is 4 centimeters, we also want them to be able to explain how they got it. And that type of reasoning is the mathematical thinking that we really care about. It is important to recognize that there are many valid explanations for the answer. And the challenge for students is to articulate their reasoning carefully. And this is where we will leave the topic of decomposing and recomposing figures.